Welcome back to our Python memory management series. Today we are diving deep into one of Python's most fundamental mechanisms, reference counting. This is the invisible force that keeps your Python programs running smoothly, automatically managing memory behind the scenes. By the end of this video, you'll understand exactly how Python tracks objects, why circle references can break your code, and how to fix memory leaks like pro. So what is reference counting? Reference counting is Python's primary memory management technique. Every object in Python has a reference count, a number that tracks how many references point to that object. When this count drops to 0, Python immediately deallocates the object. Think of it like this. Imagine a shared apartment. The reference count is like the number of people with keys. When the last person moves out, count equals to 0, the landlord can rent it to someone else. How reference counting works internally. Every Python object has a hidden structure in memory. This is a simplified C structure, where we see that every PyObject has reference count part, the part where we keep the type of the object, and the actual object data. Reference count changes when we have an increment, when we create a new reference, and it has a decrement when reference goes out of scope or is deleted. Now let's explore when do reference counts increase. I'll show you 4 key scenarios with live code examples. Let's jump right in. The first scenario, basic assignment. Let's create a list and check its reference count. When we run this code, we get 2, not 1. Why? Because there are actually 2 references here. First, the variable x pointing to our list. The second is a temporary reference created when we pass x to getRevCount function. So baseline is always 2 when using getRevCount. Keep this in mind, we'll get back to this. The second scenario, what happens when another variable points to the same object? Here is our list. Now our y is gonna be equal to our x. After y equals to x, the count jumps to 3. Why? We now have variable x pointing to our list, variable y, and of course the temporary reference in getRevCount. Important point, y equals x doesn't copy the list. It just creates another reference to the same object in memory. Let's check it with Python identity operator, which is. It just checks if 2 variables share the same address in the memory. Or even deeper, let's use the ID function to get their IDs and compare. As we see, y and x reference to the same object. The third scenario, passing objects to functions. Here's our function. Let's create our list, pass it to our function, and check the reference count after the function. So what happens? Before the function, reference count is 2. Inside the function, the count increases because the parameter object is now another reference. After the function returns, count drops back to 2. The parameter is destroyed when the function exits. Function parameters create temporary references that automatically clean up. And the last scenario, adding objects to containers. Creating our list, putting it twice in our container, And as we see, the reference count increased by 2. Here is why. Variable myList is one reference, right? First position in container, another reference. Second position in container, another reference. And of course, our temporary reference in getRefCount function. Each position in the container holds its own reference to the object. And remember, they are all pointing to the same object. If you modify myList, both positions in the container see the change. Let's check. See, now if I print the container, we'll see the changes made. And that's it. 4 key scenarios where Python's reference count increases. Basic assignment, multiple variables, function parameters, container storage. Understanding this helps you work with Python's memory management effectively. Now let's have a look at the opposite. When do reference counts decrease? I'll show you 2 key scenarios. Let's get started. First one, when we explicitly delete references with the del statement. Here we have created 3 variables, all pointing to the same list. The reference count should be 4. Remember, that includes the temporary reference in getRefCount function. Now, watch what happens when we delete references. The count drops by 1. We have removed the Y reference, so now only X, Z, and the temporary reference remain. Let's remove also the Z. It drops again. Now we are back to just X and the temporary reference count of 2. The del statement removes the reference and Python automatically decrements the reference count. When the count hits 0, Python's garbage collector can reclaim that memory. Now let's have a look at the second scenario. Automatic decrement when variables go out of scope. Here's our function. Inside the function, temp has a reference count of 2. The variable itself plus the temporary reference in getRefCount. But here is the key part. When the function ends, temp goes out of scope. Python automatically decrements the reference count. Since temp was the only reference to that list object, the count drops to 0 and the object is deleted from memory. This happens automatically. You don't need to manually delete variables. When a function returns, all its local variables are cleaned up. This is Python's automatic memory management in action. And that's it. 2 key scenarios where reference counts decrease. Explicitly using del to remove references, variables going out of scope automatically. Combined with the increment scenarios from the last part, you now understand the complete lifecycle of Python objects. If this helped you, like and subscribe for more Python content. Let's talk about getRefCount method. The most important thing to understand about it is that it always shows +1 more than you expect. As we saw earlier, we created one variable x, so the actual reference count should be 1, right? But it shows 2. Here is why. When you call sysgetRefCount, you are passing x as the parameter to the function. That creates a temporary reference inside the function, so getRefCount is actually counting itself. The actual reference is just x, count of 1. What getRefCount shows, x plus the parameter, count of 2. This is why you'll often see code that does sysgetRefCount -1. Get a true count. Keep this quirk in mind wherever you use this function. Now let's see a practical example tracking references through an object's lifetime. I have created a class with this structure, the del method, which runs when the object is about to be deleted. After creation, true count is 1. Notice I'm subtracting 1 for accuracy. Now we have 3 references total: object, reference 1, and reference 2. And if we try to delete the reference 1, of course, count drops to 2. The same after deleting the reference 2. And when we delete the final reference, the count hits 0. And watch, the destructor runs. You'll see object 1 is being destroyed. This shows Python's automatic garbage collection in action. Interesting case here. If you remember, Python caches integers from -5 to 256. What will happen if you try to get the reference count of, for example, number 5? As we see, it has massive references because Python pre-creates these integers at startup. Everyone shares the same object, save memory and speeds things up. But it doesn't work with larger numbers, for example, 2000. As we see, it has much smaller. So that's getRevCount. Remember, always shows +1, and Python caches integers from -5 to 256. I hope this video was useful for you. You can like and subscribe, and thanks for watching.